Today we are doing lesson 8.4, area of composite figures, day 2. Our I can statements: I can find the area of composite figures and I can solve real life problems. So composite figures are regular figures, that means the same thing. And we are looking at how individual shapes come together to make a figure that we need to find the area of. So we're going to start with this one that is on graph paper. So when we are estimating the area for this figure, if we have a whole square, that's going to count as one whole. If we have one that is a half of a square, so like this, then we're going to count that as 1/2. Now on this figure, and for some figures, there's not really parts that are really exactly 1 whole and 1/2. When it comes to your test, it will be either exactly 1 whole square or 1/2 square. But for our purposes today, we are just estimating the area of the garden in the best way that we can. So we're going to count the number of filled or almost filled squares, and then the number of squares that are half filled. All right, so I'm going to kind of chunk this into shapes to help me with my counting. So let's see, 1, 2, 3, 4, 5, 6, 7 times 3, this is 21. And then let's see, I have another 5 here. And then I have another 16. And these 2. All right, so let's see about how many I have. 21 plus 5 plus 16 plus 2. And when I add all of those together, let's see, 21 plus 5 plus 16 plus 2, that gives me about 44 filled or almost filled squares. Okay, so now I'm going to go through and count our halves. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So about 13. Some of those are a lot less than half. Some of them are more than half, so it kind of averages out. So we're going to do 44 for the whole squares. We're going to do 13 times a half, the half squares. So that would be like 6 1/2. And 44 plus 6 1/2 gives me 50 1/2. So our area is about 50 1/2 yards squared. All right, let's take a look at our next one here. Find the area of the irregular figure. Use 3.14 for pi. So this time I don't have little squares to count to help me figure it out. So I have to use formulas that I know. So the first thing I do is I separate the figure into smaller figures that have formulas I can use. So here, if I split this way, on the top I have a parallelogram, and on the bottom I have a semicircle. So let's start with the parallelogram. Area of a parallelogram is base times height. Base here is 16. The height is 9. Remember, in any shape that has a base and a height, they always have to form a right angle. So if they gave me the slanty side here, that wouldn't be my height. My height has to form a right angle with the base. So I'm doing 16 times 9. That's going to tell me the area for the parallelogram, and that is 144. All right, let's see, what did we do? We did 16 for the base, we did 9 for the height, we multiplied. Now we're going to do the semicircle. So it is pi times radius squared is the area of a whole circle, and then times 1/2 or divided by 2 gives us the area for the semicircle. So I'm going to go over here. I'm going to erase what I wrote for the parallelogram so I can see the semicircle a little bit better. 16 is my diameter. It goes all the way across the middle. But I need my radius. So to get my radius, I'm just going to do it off to the side. I have to do 16 divided by 2. That's going to tell me that 8 is my radius. That's this part right here. I'm trying to figure out the area for this semicircle. Okay, so I'm going to do 3.14 times 8 squared. 8 is my radius. All right, so 3.14 times, if I did the 8 squared first, it would be 64. You could have also written it this way. I'll do it off to the side. 3.14 times 8 times 8. Instead of writing 8 squared and then finding that as 64. And then we do need to either divide it by 2 or times 1/2. It all means the same thing. So let's see, 3.14 times 64 and then divided by 2. That's going to give me 148 hundredths for my semicircle. So now I'm going to add the two parts together. 144 for the parallelogram, 148 hundredths for the semicircle is going to give me 244 and 48 hundredths. Let's check. Did they ask us to round? No. So that's going to be 244 and 48 hundredths meters squared. All right, let's take a look at this next one. The Wrights want to tile their entry with square foot tiles. How much tile will they need? So this is a story problem situation looking at irregular figures. So the first thing we need to do, we're going to look at our question as a statement. So we need to find the amount of tile needed to cover the entry. And then important information, the entry is an irregular figure. And I know to figure out the amount of tile needed, that's going to be the area of the entry. I'm not calculating perimeter here. I'm calculating area. Okay, then to make a plan, I am going to separate that figure into familiar figures, things I have formulas for. So I see a rectangle in the top part, and I see a trapezoid on the bottom part. So I'm going to find the area of both of those shapes, and then I'm going to add them together. So let's go ahead and do that. Let's start with our rectangle. So the rectangle is the top part. We do length times width, and again, length times width or base times height, it's really same thing, have to form a right angle, and we can see that 5 and 8 do. So 5 times 8, area is going to be 40 for the rectangle. Our formula for a trapezoid, 1 times half times height times the sum of the bases. The bases on a trapezoid are the two sides that are parallel. This is a base. It's going to be 5, the same as the top part of the rectangle. And this is a base, 7. They're parallel to each other. Those are going to be added together as our first step. And then the height is parallel to both of those bases, and that is this number 4. 5 plus 7 is 12. So we're going to do 1/2 of 4, that's 2, times 12, that's going to give me 24 as my area, my trapezoid. And then I'm going to add those together. 40 plus 24 gives me 64, and that's going to be feet squared, 64 feet squared of tile. And then, of course, it's always a good idea at the end of any problem, but especially story problems, to look back and see, does that make sense? So it says the area of the entry must be greater than the area of the rectangle, which would be 40 square feet. So yes, our answer is reasonable.